So on page 248 of our books here, we're going to look at proving triangles are congruent using the side angle side. So yesterday all we looked at was dealing with angle side angle. Now we're going to look at side angle side. Okay? And see what kind of stuff arises from there. Okay? So the directions here are to write each proof. Okay, so our setup here is we're supposed to write a proof to show that the two halves of a triangular window are congruent if the vertical post, so that's like that vertical post right there, is the perpendicular bisector of the base. Okay, now that word perpendicular bisector, right, it's made up of two words, perpendicular. Okay, and we know perpendicular means what? What does it mean to be perpendicular? Yeah, Evan? What's that? They do intersect each other, but more specifically, they intersect each other at what kind of angle? A 9-degree angle. So perpendicular means they meet at a right angle. So that means this vertical post meets this bottom side here as at a right angle. And then the bisector part, what does that mean? So not only does this vertical post meet the bottom side here at a right angle, but what does it do to that bottom side? Yeah. So cuts it in half. Exactly right. Exactly right. Okay. So we took this picture here, and then they kind of showed it right here. Okay. And so the given information is that BD is the perpendicular bisector of segment AC, side AC, and we're supposed to prove the triangle BDA is congruent to triangle BDC. Okay, and so let's go ahead and just write that information down. Well, they already have the right angle drawn in there. We should also mark in what Stephanie said, that AD is congruent to DC. Okay, and then I see that there's not really a whole lot of space here. What to do? I don't really want to do that. Alright, well, I'm not sure what to do here. What we could do is, well, here's what I'll do. You guys just follow along with this one, and we'll do it together. They already have a proof written out here in what is called paragraph proof form, okay? You can see they're basically just like each statement and reason is given in a single sentence, okay? So, for example, you can see the very first sentence is your given. It is given that segment BD is the perpendicular bisector of AC, and then they go through the proof just using sentences instead of the kind of two columns. But I'll do a two-column proof here. If you guys want to follow along and just not copy it down, that's fine by me. Okay? So we'll look at that here. Statement, oof, that was not a very good line. And reason. Okay? So, Statement 1, right, it's always stating the given. So BD is the perpendicular bisector of AC. And again, the reason for that is it is given. Okay, so I took care of the easy stuff for us there. Okay, now notice, in this given statement, there are no congruences given to us, which means we need to come up with our own congruences. Okay? So, Stephanie, from what you said there, what's the congruent statement that I could write? So you said that, you know, this cuts AC into two equal parts, right? So how could I write, what congruence can I write here then? What is congruent to what? AD, good, is congruent to DC, beautiful. Okay? So, if y'all want to head out, we'll see you. Have a good run. It's a beautiful day. Okay. Don't twist an ankle. And so that's true. And then again, Stephanie, how did you know that they were congruent? What was the piece of information that told us that? Yep, exactly. So that's our reason. BD is the perpendicular bisector of AC. Okay, so there we got our first congruence. All right. Is there anything else we can say is going to be congruent based on our picture here? So, Elizabeth, what do you say? Okay, so can you name the angles? What are the angles here? Very good. And Elizabeth did something very good there. She named the angle using the three-letter name. Okay? Very important there. If we just say, oh, angle D, well, it's like, which angle D are you talking about? You talking about this angle D? You talking about this angle D? You talking about this angle D? Okay, you need to use the three-letter name there. So she did a real good job with that. ADB, that's talking about that right angle, is congruent to BDC, that right angle. Okay? And how do we know those two things are going to be congruent? Because they're both, yeah, it's perpendicular bisector. Good luck, Haley.
Thank
Yep.
you.
Okay, and I'll just say that BD is perpendicular. I'm going to use the perpendicular symbol. I don't know. I feel like we've seen this before, but maybe not, right? That symbol means perpendicular. So BD is perpendicular to AC. Okay, so we're told that. All right, great. We've got two congruences. We need one more. What's one more congruence we can come up with here based on this picture? I guess I'll put in the other right angle there so you can see that. What's one other congruence we can have here based on this picture? Any ideas? Oh, Drew, what you got?
Segment BD equals segment BD.
There you go, right? It's like right there. Okay, BD is congruent to BD. And what's the reason for that, Drew? Reflexive property, right? Something is congruent to itself because of the reflexive property. Okay, it's so obvious. Do we really need a property? But according to math, we do. So we got our 1, 2, 3 congruences there. I'll go ahead and mark that one in as well. Okay. And so our last step then, all right, our last step here is to show these two triangles congruent. So we've got it. So we now have those three pieces of information. That's enough to say, we have enough information now to say that triangle BDA is congruent to triangle BDC. Okay? You may name the two triangles. You may name the congruence however you, if you'd like to, just make sure that corresponding parts match up. But I always like to just use the proof statement. It's already written in the correct order, so, why spend the extra time? What, though, is our reason for saying these two things are congruent? How can we now say these two triangles are congruent? Yeah, Elizabeth?
Side angle side.
Very good, yes. Side, angle, side. We have this side congruent for both triangles. We have these two sides congruent, and then the angles between them. Okay? So that's why it's side, angle, side. Do you see that, Mason? Does that make sense to you why it's side, angle, side there? Side, and then the angle on the side is congruent to the side, this angle on this side. Side, angle, side. The angles between the two congruent sides. So, okay? Easy, very easy problem. All right? Now let's look at this one. Okay, so letter B. And there are like blanks in there and stuff like that, but I don't know if I want to go through that. I don't know if I like their method yet. And we haven't talked about paragraph proofs yet, so I don't want to worry about that just now. Okay? So let's give this one a shot here too. Okay? And again, if you don't want to write it down, you can just follow along with me here. So do statements, reasons. Okay. So we're told here that segment CD, so CD bisects segment AE, and AE bisects segment CD. And we want to prove that the triangle ABC is congruent to triangle EBD. Okay. So you guys can lead me through this here. So let's go to. So Mason, what should my first step be here?
Segment CD bisects segment AE.
Yep.
AE bisects CD.
You got it. So we're just going to restate the given, right? So there's that, and then AE bisects CD. Okay. Sometimes they have us, Mason. I don't know, you didn't see this yesterday, but sometimes on the book they give you they want you to do that in two separate steps. You can also just do it in one step too. It's just the same thing there. So, all right. Let's see here. Oh man, it's really random. Not really. Okay. So next step, Michael. Based on that information, can you come up with any sort of congruence here? Some part of these two triangles that must be congruent based on any of this information? Okay, so that's true, but I think so look what you named. You named angle ABD, which is this angle right here, and CBE, which is this angle right here. Those two angles are not part of our triangles. They are congruent, you're right, but can you name, but they're not part of the triangles. So can you name angles that are part of the triangles?
ABC and DBE.
There you go, that's it, yes. So angle ABC is going to be congruent to angle DBE. You're right, Michael. Why is that true?
bisect each other.
It doesn't actually have to be that they bisect each other. It's the way it's drawn here. What special angle relationship do we have with these two angles that are opposite one another like this? Forget the name?
Yeah.
All right, somebody? Vertical angles. That's right. Vertical angles are congruent. Very good. Okay, so actually I feel like that's like not going to be, it's a little bit harder because that's not gotten from this given information. You have to kind of just see it in the picture there. Okay, so there's one congruence. All right, we come up with another one though. Let's go to, I want to fix my hand to Shannon. So what do you say, Shannon? What other congruence can we come up with here? Maybe using some of the given information. What could we say? There you go. Yep. AB must be, segment AB must be congruent to segment BE. Because why? There you go. That's what I'm looking for. Yeah. CD bisects AE. Okay. So absolutely. So now we have two congruences. We need one more. All right, and so Adam, what's another congruence you could write here? So I'll mark in what Shannon wrote right there. Sorry.
Segment CB is congruent to segment BD.
Yep. Very good. And what's the reason for that one? Why is that true?
Segment AE bisects angle, no, not angle, segment C.
Beautiful. Exactly right. Exactly right. Okay, we've got 1, 2, 3 congruences there, and so we can finally state our last step here, which is going to be, what will that be? Oh, Mary just left. Sorry, Mary. All right, Elizabeth. What's our last step then going to be here? We've already got our 3 congruences, so now we're ready to do our last step. So it's going to be, angle side. Well, not quite. Side angle side. There you go. That's going to be our reason, but then what do we state here, though? There you go. Very good. And remember, angle side side is not a congruent statement. You're going to end up calling Mr. Whitmire names if you write angle side side down. Okay. Okay. Cool. All right. Well, there's another one for you guys. Believe it or not now, I've got one for you to try. Page 249. So if you turn the paper over there, I'd like you to go ahead and give that one a try, okay? So, given the information, prove those two triangles congruent. They're at the top of page 249. Okay, and you may need to, you may need to, write out your little table there for it as well. Okay. Bless you.
that's not the, symmetric would not be the reason for that. Because it's something congruent to itself. So the reason it reflects. So you already have two congruences, so you really need one more. Or AC, yeah. Very good. So you can see here from the given that you already have two congruences, so you really only need to come up with one more congruence. So you have A, B, and really when you see it, when you're told a congruence, you should mark it in there. And 1 and 2 are congruent as well, so I'll mark those in. So looking at your picture here, because you don't really have any other information up here to use, there are already congruences. So what can you see? What other part must be congruent between these two triangles? How do you know? So in this case, the reason why you don't know is because you can't say that's true. Okay? So you don't have enough information to say that BC and BC are congruent. But what else could be congruent? Or must be congruent? Right. Well, that's what we kind of took care of because we labeled them 1 and 2. So we already know they're congruent. We already kind of said they're congruent. Well, again, what are you trying to do? You're trying to prove this triangle here is congruent to this triangle here. Yes. Well, segment AC is congruent to itself. It was actually congruent to that part. Yep. It's shared to both. You got it. Okay. So you're stuck on the third congruency. If it's helpful, you have that command line for data. So you already have those on that side. These are also. What else can you say is congruent? You don't really have any more information to use here to kind of get congruence with the picture. What can you see in the picture must be congruent in these two triangles? What would be congruent? 1 and 2 will be already given to us. So what else? Besides the congruence there, besides 2 and 2. What else must be congruent? This one and this one? Why? Are we told that? So, I mean, I guess AC is a bisector of this angle. You're right, but it doesn't necessarily mean these two sides. But, again, look at what you're trying to do. You're trying to show that this triangle is congruent to this triangle. So, what do those two triangles have in common? What do they share? Close, but here's the thing. This side and this angle, they do match up with this side and this angle. There's no, because you need a third side. So what's the other, so what I mean is not a third side. You need a third piece of information, which is a second side. So what other side do they have in common? That would be one pair. So far, what's the pair outside? Let's match up. So look at your triangles. ACB, ACD. What else are you trying to share? So AC is congruent. AC. All right.
Here we go. All right. So step 1, gosh, I should have had that written down for you already because everyone knows that one, right? No one's going to leave their proof blank because they all know that at least you got to start with the given. Okay. And then the next step here, okay, Melissa, what's going to be the next step here? Very good. Okay, and if you haven't kind of figured it out now, one thing you always want to keep your eyes out for are these reflexive properties. When you have two triangles sitting next to each other like that, right, sharing a side, use that congruence, right? There's a good like they don't just put the authors of these problems don't just put them together like that, put them next to each other without really expecting you to use that reflexive property. There's a good chance you're going to use that. So please keep an eye out for that, okay? When they share a side like that. All right? And so then the next step, all right, is going to be what here, Julia? What do you? Oh, she left. Sorry, Julie. Then we'll use you, Julie. What's going to be our next step here? Ah, okay. So, but actually, so we're done here. Actually, we don't even need that piece of information. Okay. Now I see what you're saying. Because like AC bisects angle BAD, then therefore it's going to bisect this one, and that's not technically true. It could be true, and in fact, it will be true in this case because we know they're triangle congruent. But we're actually done. We have our 3 congruencies here. So what actually can be our last step here?
Triangle BAC.
Yep. There you go. And what congruence do I have here? A side, angle, side. There it is. Okay. So that's all there is to that one. Okay? All right. So we're going to scoot on from this one. Okay. Yes, I will give you guys a homework assignment from it, but not just yet because I want to look at another section here, which is side, side, side. Okay. So maybe like, I don't know, bookmark that or, hold on to it or something because we are going to come back to it. Then skip on. We're going to look at a side, side, side congruence, and I think we're going to start with, let's see here if I can find what I'm looking for. Side, side, side. Oh, jeez. Wow, there's actually no proofs for this one. Okay. Well, so there are no proofs for the side, side, side section, so we'll just take a look here at, it's very funny, but basically the idea here is for this is you're looking to try and prove that more than one side is congruent. You know what, I'm going to just come up with one because I know that I've got some here, so I'll just come up with one real quick. Okay, so let me see here, I've got some, I think. Okay. Yeah. Okay, so here's one that I've got. I'll just show it to you guys, okay? So this one's going to be kind of like separate, so that way we can just say we've got one side, side, side proof under our belts here. Again, if you want to just follow along, that's fine, okay? But here's going to be the situation. So our given information is going to be that triangle PST is equilateral, okay? And that E is going to be the midpoint of segment TS. Okay? So this will be the last proof we do, and then I'll give you guys your assignment and stuff like that. Okay? Which will leave you oodles of time to get working on it. And our goal is to prove that triangle PET is congruent to triangle PES. Alright, and I'll draw a quick picture of what that's going to look like here. So pardon me while I just turn my paper so that way I can draw. This quickly, okay? And so this is going to be triangle okay, that's one of our triangles right there. Whoop. Wow, I can't read. PST, there we go. So this triangle is our equilateral triangle, and then we have another segment TS that has a midpoint of E. Okay, and we'll join that there from P. Okay, and so there that creates our two triangles we're trying to prove congruent. We're trying to prove that PET is the same as PES. Okay. So there we go. Okay, so there's our situation. Okay. our little two columns over here. Statements and reasons. Okay? Alright, so Keegan, what's going to be the first step here in our proof? Oh, sure. I'll go ahead and do the first step, right? I guess everyone knows what that one is. And I just write triangle PST, right, is equilateral. And E is the midpoint of segment TS. And that's the given information. Okay. So that's the given. So that gives us our starting point. Notice in the given statement we are not given any congruences. So we have to come up with all three and, at least the next three steps, right? Okay, we have to come up with them on our own. We don't have any given to us. We have to come up with all three. Okay? So Keegan, can you come up with a congruence here based on one of these pieces of given information or something from the picture? What must be congruent?
Well, EP is equal to itself.
Aha, so EP is congruent to EP or PE is congruent to PE, whatever you want to say there, that's right. Okay, good, that's good that you're looking out for that. And that was the reflexive property you said?
Yep.
Yep, and you are right. Okay, so that takes care of one congruence. We got this guy right in the middle. Boom. Alright, what else though? Can we see another congruence? What other congruence can we come up with here? Yeah, Hunter, what you got for me?
PS is congruent to PT.
So say that one more time, sorry.
PS
PS.
is congruent to PT.
Okay, how do you know that?
Because the equilateral has all three equal sides.
Yeah, so triangle PST, this big triangle here, that's formed by putting the two together that we're trying to find congruent, the two that we're trying to find congruent, put them together, creates this big triangle, and it's an equilateral triangle. So PS must be congruent to PT, and he's exactly right. Hunter's exactly right, because triangle PST is equilateral. Okay, all right, that's a second congruence. Just need one more. What else can we say is congruent here? Drew?
Segment SE is congruent to segment ET.
SE is congruent to ET, you said? Okay, and what was the reason for that? How do we know that's true?
Is it because it's equilateral? Or, no, because E is the midpoint.
There you go. Yep, we have that one piece of information right there. E is the midpoint of segment TS. So then marking that in, okay, we can do our last step here. And so, Tanner, what's going to be our last step here? What's our fifth step? Yep, triangle PET is congruent to triangle PES by side to side. You got it. Okay, and that's the end. Alright. So there's a side-side-side proof, just so you guys can say you got your money's worth today and didn't miss out on that side-side-side proof. Okay? So, let me then give you guys your assignment here. Okay? And you guys can get started on that. You have quite a bit of time.